Electromagnetic waves are waves that can transfer energy from a source without having to travel through matter. Now, this is the key property that distinguishes mechanical waves from electromagnetic waves, or EM waves for short. Though you don't need to understand how it's possible for a wave to cause vibrations without matter. Let's look at an example which demonstrates that electromagnetic waves can travel without matter. Here's the Sun and the Earth, with the Sun having to supply energy to the Earth. But this energy has to travel through space, which is a vacuum and has no matter which can vibrate. It does so by using electromagnetic waves. These waves will travel through space and reach the Earth. Again, since there is no air or other matter in space, these cannot be mechanical waves. They have to be electromagnetic waves. The Sun emits multiple types of waves with different properties. These together will provide light and heat to the Earth. Without these waves, the Earth wouldn't be at the correct temperature to support life, and plants wouldn't gain the energy needed to start food chains. Now let's look at some things that all electromagnetic waves will have in common. All electromagnetic waves are transverse waves. A transverse wave is when oscillations are happening perpendicular to the direction a wave is travelling in. Again, at GCSE, you don't really need to understand what exactly is oscillating in an EM wave. Here are 3 examples of devices which emit different types of EM wave. A satellite dish can emit microwaves for communication. A lamp in a sunbed can emit UV, also known as ultraviolet waves for tanning. And a torch emits visible light to let us see. Despite being different types of waves with different uses and properties, if we draw their wave patterns, we can see that they must all be transverse waves. This is the same for any wave which can travel without matter. But what else will all of these waves have in common? Well, all electromagnetic waves travel at the same speed in a vacuum. Remember that the speed of a wave can be calculated by multiplying its wavelength by its frequency. And we can write this as the equation V equals lambda f, where lambda is the wavelength and f is the frequency. With these 2 types of EM waves, their frequencies and their wavelengths will be different. We can see this from how the distance across which the pattern repeats in the torch's wave is shorter, signifying that it has a shorter wavelength. However, both of these waves will have the same speed. This means that although the visible light has a shorter wavelength than the microwave, it must also have a greater frequency. This balance between the 2 is what allows the waves to have the same speed. The speed of an electromagnetic wave in a vacuum is 3 × 10⁸ meters per second. This is a very important value in physics, usually referred to as the speed of light. In an exam, this value will always be given to you when required, but you need to remember that it will apply to all types of EM wave.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE physics course. See you there!